You need to know them by their look. So question 1, what solid is this in item 1? Okay, so this is a pyramid. A pyramid is any solid that has a set base shape. In this case, it's a square. The sides all meet up at a point at the top. The sides, the faces, are always triangular in a pyramid. And the volume formula for a pyramid is base times height divided by 3. Base meaning base area, which we find length times width for a square or rectangle. Please compute the volume of this pyramid. All right, using the formula, what we should have done for base area, we have 7 times 7. The height of the whole thing is 12, and we're dividing that by 3. This one's a nice one because the 3 goes into that height. Anytime you have one of the measurements divisible by 3, then the problem cleans up nicely. Using my calculator, because you can do that, divided by 3, I get a volume of 196. And don't forget, these are centimeters cubed or cubic centimeters. Now please look at item 2. What is this solid called? So this solid is called a cone. And we know that because it has a circular base, but it goes to one point. And you're probably familiar with this, right? You see the cones on highway construction sites. You've got ice cream. There are a lot of versions of cones. Snow cone, if you will. All right. Formula. It's the same as this, but instead of base area being length times width, it's pi times radius squared times the height of the cone divided by 3. For problem A, please compute the volume of this cone in terms of pi. Here I go. Pi times radius squared, times height all over 3. Notice the diameter was 24, so we had to cut it in half for the radius. I'm going to reduce right here. So now what we really have is just 12 times 12 times 10. So that's 144 times 10. So that would be 1,440. And then pi sits on the end. And this is cubic or cubed inches. Please now compute the decimal version of that answer. If you used your calculator correctly, 1,440 times 3.14 is 4,521.6. So this is the pyramid and the cone. They have very similar formulas. Number 3, we are going to be solving for the length of the arc as well as the area of the sector. So these were the first 2 lessons you learned. The formula for length is angle times 2 pi r all over 360. Please find the length of arc AB and leave your answer in terms of pi. So the central angle is 45 times 2 times pi times the radius, which is told to us to be 7 all over 360. 45 is one of those angles that divides nicely into 360. If you do 360 divided by 45, it goes in 8 times. Let me double check that every now and then, I think. Yes. All right. So now I've got 2 times 7, which is 14. I have an 8 on the bottom, and then that pi is just sitting right there. And what units do we have? Inches. There you go. Please now, let me review it first. Area of a sector. Area looks a lot like this, but instead of 2 pi r, it's pi r squared. Since area has square units, the formula also has a squared radius. Angle times pi times radius squared all over 360. By the way, if you hear that cat, that's my cat who thinks he's starving all the time. He is hungry all the time. Please find the area of the sector and leave your answer in terms of pi. All right. Angle times pi times 7 squared all over 360. Good news. If you do that problem with the same dimensions, the reducing works right here the same way. So what do we have? We have 7 times 7, which is 49. We have the pi, boop, and then the 8 on the bottom. And this, this was, my apologies, you caught me. This would be normal inches because it was length. This is inches squared for area. All right, please look at number 4. What solid is that? So this is a type of prism, and we know that because we have a base and a base that are identical. And then the sides connecting all of those are rectangular. So it's a prism, and it's called a triangular prism because the bases are triangles. The volume for a prism is simply base area times height. If it's a triangle, this formula is length times width divided by 2. And then you're going to multiply that times the height, which means how long that prism is. Please compute the volume of this triangular prism. Good news, I gave you the length and width because it's a right triangle. If this had been a kind like this kind, you would have had to divide and do some Pythagorean theorem or something. But good news for you, I gave you a right triangle, which means the two that make the right angle are your length and width dimension. So 4 times 8 is length times width, and we're going to divide that by 2, and we're going to multiply all of that by 12. This is 32 divided by 2, which is 16, and we multiply that times 12. And that is 192 cubed yards, or cubic yards, or yards cubed. Number 5. Please tell me what solid this is. So this is a cylinder. You could say a can, but the mathematical term is a cylinder. And like the prism, they have very similar formulas. Base area times height is the volume. The only difference is you don't have to think so much because base area for the cylinder is always pi r squared. So you're simply multiplying that and multiplying that value times the height of the cylinder. Please find the volume of this cylinder and leave your answer in terms of pi. So we have pi times 6 squared times 8. Be careful with the order of operations. Make sure you're squaring only the radius. Okay, if you do 8 times 6 and then squared, it might square up both of those numbers together. So you got to be really careful. So I'm going to go 6 times 8, and that is 288. So this is 288 pi, and we don't have any units, so it's just cubic units. Last page. Now this relates to today's lesson. So all the problems on this page have the sphere. So number 6 is the sphere, which looks like a ball. First problem, please find the volume in terms of pi, knowing that the formula for today is 4 times pi times radius cubed, all divided by 3. Find the volume in terms of pi. So here we go. 4 times pi times 18 cubed all over 3. Okay. I know that 3 goes into 18 evenly, so I know this problem won't have a decimal when I'm finished if I just multiply everything and leave the pi alone. So I'm going to go ahead and go 4 times 18 times 18 times 18, and I'm going to divide all of that by 3, and it shouldn't be a decimal. It is 7,776. Don't forget that pi. And I didn't have units, so that's units cubed. It was an 18 there, so it's big. Please now compute that volume in terms of a decimal by replacing pi with 3.14. So I've got my 7,776 in the calculator. I'm just going to multiply that times 3.14. And I get to 24,416 point, wait for it, 6 units cubed. And finally, the tennis ball can problem. Pretend that these tennis balls fit perfectly in the can with no extra air space. The lid rests right on top of the very top ball. This can is 6 inches in height, and I'd like to find the volume of the space between the balls and the can. In order to do that, we need to find the volume of the can, find the volume of the 3 balls. These will be in terms of decimals, okay? And then subtract them, because all this area around is what's left over if you took the balls out of there. So before we begin, if the height is 6, what is the diameter of each ball? So these are distributed, they have to be the same dimensions to fit in the can this way. So if 6 is for 3 balls, then each ball has a diameter of 2, right? Which means that the can has a diameter of 2, and these each have a radius of 1. These are important. Please find the volume of the can. All right, so the can's volume is pi r squared times height. So I'm going to go pi times r squared times height. And remember, I'm using a calculator, so we don't have to worry about reducing. So 3.14 times 1 times 6. So this is 18.84. Okay, we now have the spheres, the balls, and there are 3 of them. Please find the volume of a ball, and then from the answer choices, what would the volume of all 3 together be? So each ball would be 4 times pi times radius cubed all over 3. That would be 1 ball. And here's the thing, 1 times 1 times 1 is just 1, so it's not that very exciting. But we're going to then multiply all this by 3 for all 3 balls. Magic, this is going to cancel right here. But I'm going to go ahead and use my calculator so that you don't think it's like you had to have seen that. So we're just going to go 4 times 3.14 divided by 3. And that for 1 ball would be 4.18 or 4. I'm going to round to 2, 4.2, but there are 3 of them. So that would be 12.6. So I have the can, I have the 3 balls. Please now compute the volume of the space left over that's in the can around the balls. So we just subtract, and that answer should be 6.2. And this was inches. Voila! Reminder, this chapter exam should be very successful. Make sure you have your formulas figured out. Know what type of shape each is by looking at it. Thank you very much.